In this work, we design and control an expressive bipedal robotic character by combining methods from legged robot design, learning-based control, and character animation. Our robot is remote controlled with a puppeteering interface, which allows for expressive performances to be created on the fly. We begin by iterating on the mechanical design in parallel with authoring animations to develop our robotic character. Motions are created using a custom stylized gait generation tool, as well as standard freeform animations. In the design phase, we use these tools to study the movement of the character and estimate kinematic and dynamic requirements. By leveraging off-the-shelf hardware modules, we can iterate quickly. The final robot design has 5 actuators in each leg and 4 in the neck. It also has a set of show functions: speakers, actuated antennas, illuminated eyes, and a headlamp. These show functions in audio are controlled elements of the robot that do not affect the dynamics of the system, but play a key role in expressing character. The onboard PC, battery, and other electronics allow the robot to roam freely for up to 1 hour. We then use reinforcement learning to train control policies, asking for a simulated robot to balance stably and to track the motion of prescribed animations. The simulator is augmented with a low-level controller and actuator models, which we derive from real-world data, reducing the sim-to-real gap. The artist-specified reference motions are parameterized by command signals, such as walking velocity and robot pose, and are randomized during training. The policies are conditioned on those same commands and trained to imitate the corresponding reference motions using PPO. Reference animations fall into 3 atomic categories. Perpetual motions, such as standing, have no clear start or end and continue indefinitely. Periodic motions, such as walking, have a cyclic nature. Episodic motions, such as animation clips, have a predefined duration. For every motion, a separate policy is trained. For walking motions, we use a procedural gait engine to generate stylized walking references at different velocities. During runtime, trained policies are deployed to the real robot. The animation engine receives input from the operator and fuses animations from a database with the joystick commands. Based on that, it selects which policy to activate and streams the appropriate conditional inputs to the active policy. The policy outputs actuator set points and is fed back the estimated robot state. Additionally, the animation engine synchronizes the control of show functions and audio. Here, a standing policy is driven through its command range. The reference corresponding to the commands is seen in blue. Here is a walking motion. There is good agreement between the robot motion and the stylized reference that was used to train the policy. The robot transitions smoothly between different policies. Here we showcase our set of episodic policies. These can be triggered with buttons on the remote control. The robot can robustly walk over uneven ground. Robustness is obtained by using domain and terrain randomization and by applying random disturbances during training. In this ablation study, we compare the policy output of our method, which is trained with the full kinematics reference in the reward, to versions where we ask to track the body velocity and foot contact state, and where we track the body velocity only. it can be seen that only with the full body reference are we able to capture the nuances of the reference motion, such as head and body tilt. The robot performance is composited from several layered animations. A background animation conveys a basic level of activity. The operator can trigger predefined sequences which are then blended with a background. These sequences can then be further modulated by adding joystick animations which are layered on top, for example to add head turn. During standing, the operator primarily controls the robot posture with one joystick and the robot gaze with a second joystick. The functional separation allows the puppeteer to more easily direct the robot's line of sight while simultaneously modifying the body posture to convey emotion. With the presented remote control interface, complex performances can readily be created. As shown here, the operator is able to combine procedural walking, predefined animation sequences, and joystick animation to create a seamless show where transitions are barely perceptible. We end with some additional demonstration sequences.
Hi! Aw. Aren't you so cute? What do you see? Look, it's your friends. Let's go say hi. It's okay. Let's go say hi. Come on, don't be shy. It's okay. They're your friends. Let's go. Don't be shy. Come